Construction. Sulfur hexafluoride circuit breakers are constructed in three ways: non-puffer type, single pressure puffer type, double pressure puffer type, non-puffer type. The image shows the constructional details of the sulfur hexafluoride circuit breaker. It contains an arc interruption chamber. In the arc interruption chamber, fixed and moving contacts are enclosed and is filled with sulfur hexafluoride gas. The chamber is connected to a reservoir. Valve mechanism passes sulfur hexafluoride gas at very high pressure during separation of the contacts of the breaker. The gas flows from the reservoir with a high pressure towards the arc interruption chamber. The fixed contact is hollow and cylindrical in shape. It is a current-carrying contact fitted with the arc horn. The moving contact is also a hollow cylinder and contains holes on its sides for the sulfur hexafluoride gas to pass through them after flowing across the arc. Working. When the breaker is closed, sulfur hexafluoride gas at a pressure of about 2.8 kg per centimeter square encloses the contacts. When the breaker operates, the moving contacts get separated from the fixed contact and an arc is struck between the contacts. The movement of the moving contact is synchronized with the opening of a valve which permits sulfur hexafluoride gas at 14 kg per centimeter square pressure from the reservoir to the arc interruption chamber. The sulfur hexafluoride gas flowing at high pressure absorbs the free electrons present in the arc path rapidly. Then it forms immobile negative ions which do not serve as charge carriers. As a result, the dielectric strength of the medium between the contacts rapidly rises high and the arc gets extinguished. After the breaker operation, that is, after arc extinction, the valve is closed by the action of a set of springs. Single pressure puffer type. The puffer type sulfur hexafluoride breakers of single pressure type are the most favored type prevalent in power industry. Working. The piston is fixed but the cylinder is movable. The cylinder is fixed to the moving contacts because the cylinder along with the moving contact moves away from the fixed contact when the breaker is operated. The sulfur hexafluoride gas in the cylinder is compressed as the fixed piston is present. The compressed sulfur hexafluoride gas flows through the nozzle and over the electric arc in axial direction. Owing to the convection and radiation of heat, the arc radius reduces gradually and finally gets extinguished at current zero. The dielectric strength of the medium existing between the separated contacts increases rapidly and is restored quickly as a new sulfur hexafluoride gas occupies the space. During the quenching of arc, a small quantity of sulfur hexafluoride gas breaks down to some other fluorides of sulfur which mostly recombine to form sulfur hexafluoride again. A filter is used in the interrupter for absorbing the decomposed byproduct, that is remaining. The gas pressure inside the cylinder is maintained at around 5 kg per square centimeter. At higher pressure, the dielectric strength of the gas increases, but at a higher pressure, the sulfur hexafluoride gas liquefies at high temperature, which is undesired. Hence, heater is required to be arranged for automatic control of the temperature for circuit breakers, where higher pressure is utilized. If the sulfur hexafluoride gas will liquefy, then it loses the ability to quench the arc. Double pressure puffer type. During the process of arc extinction, gas from a high pressure system flows into a low pressure system through the nozzle. In this circuit breaker, gas is made to flow from zone P1 to P2 through a convergent divergent nozzle. The nozzle is located such that flow of gas covers the arc. Gas flow attains almost supersonic speed in divergent portion of nozzle, thereby taking away the heat from periphery of arc, causing reduction in diameter of the arc. Finally, the diameter of the arc becomes zero at current zero and the arc gets extinguished. Arc space is filled with sulfur hexafluoride gas, which increases the dielectric strength of contact space.